Hey everybody, welcome to week number 2 of Generative AI for Journalists, Discovering What Data Can Do. I'm your host, once again, Sil Hamilton, and for this week, we'll be discovering your data. That is what the topic of this week will be. So 2 weeks ago, in the introductory module, we talked a little bit about using something called JupyterLab Desktop, which is a programming environment that lets you use Python on your computer to run language models locally. And we also talked about Hugging Face, which lets you download language models to your computer. Then, the following week, in week number 1, we spoke, both with John Keith and ourselves, about what data is, what data can do. Then, in week number 1, we talked about what data is, and what a language model is, and how language models can be useful, and why they're useful. And through that history, a little bit of both the artificial intelligence, neural networks, generative AI, we learned a little bit about what language models are really capable of. And we discovered that it's understanding the world. ChatGPT is really so impressive because it understands the world. It understands us, it understands the world, it understands how the world fits together, it understands little particular things like who won a particular Stanley Cup, or it also understands bigger things like what America is and what Canada is and what the rest of the world is. And so generative AI is interesting not only because it can just make you images, it can write your essay, but also because it belies a deeper, more serious and something to contemplate on, this more serious fact that the world is a little bit predictable. That artificial intelligence, which itself was coined by its originators as simulating human intelligence, to simulate someone is to predict what they might say. And prediction, to be able to predict someone well, is to have a model of that thing. And so artificial intelligence, generative AI, is impressive not only because of what it can do, but why it can do it. And so to make proper use of generative AI, this week we'll be discussing embedding, and we'll be discussing data, and we'll be discussing LangChain. So to begin, when we talk about making use of generative AI in the newsroom, we have to think of a couple of things. So first of all, what can we do with generative AI? And really the question is not what can generative AI can do for us, but rather what can we do for generative AI? How can we best make use of it? Well, let's take a look at what kinds of data we have. Newsrooms have a lot of data. They've got photo archives, they've got print archives, they very often have social media archives. They've got lots of documents sitting around. They have transcriptions from interviews that reporters might have done. They've got random miscellaneous documents from various levels of government sitting around. They have a lot of information. And I'm here to tell you that generative AI, the best way it can be made useful in your newsroom is to bring that data to life. And so, for week number 2, we'll be discovering your data and discovering, more specifically, how to hook your data up to a language model. And so, to begin, what is data? What do I mean when I say data? Data can mean a lot. Is data that person in Star Trek, or is data my images, documents, and audio? Probably the latter. So data, when we say data in a data analysis context, what we really mean are images, documents, audio. Pretty much if you have a file of it on your computer, that can be considered data. So if you have a PDF, a Word document, if you have a spreadsheet, if you have JPEGs, PNGs, if you have MKV files, MOV files, if you've got MP4, if you have MP3 files, FLAC files, any kind of data resting on your computer is technically data for data analysis purposes. And so the key is hooking this data up into a language model so that a language model can take a look at the data, make sense of it, and try to give you information that you may have not thought of otherwise. And so to make a document understandable so that a language model might understand it, we have to think back to week number 1. So last week I talked about how language models actually make sense of words. And I mentioned that language models make sense of words by turning those words into numbers. And so in order to make your data understandable to a language model, you also have to turn your data, your PDFs, your documents, your photos, into numbers that the language model will understand. And in fact, we do this very same thing every time we talk to a language model. When you talk to ChatGPT and you type a little bit of text into the model, it is turning your words into numbers. And then it thinks in those numbers, it moves those squares and cubes around like we saw in that visualization, And then out comes a prediction. It predicts what the next word should be. And when you do that over and over and over again, and especially when you give ChatGPT its own prediction and predict the 50th word, and then the 51st word, and then the 52nd word, and so on, eventually ChatGPT produces cogent and rational text. So, in order to make our miscellaneous documents readable by machine language, by language models, we are going to be embedding. And embedding is a really important term, and as you work more with generative AI technologies, you'll see this term come up and up. But again, what embedding is turning your documents into a series of numbers helpful for language models to understand. That's all it is. So you take your document, like your PDF, like your PowerPoint file, you turn it into a series of numbers, you store those numbers in a database, and then you let your language model talk to the database to retrieve information from that database. So let's take a newsroom, for example. You might have a digitized archive. And this archive might be pretty big, depending on the age of your organization. It might, for example, have, say, 50 years worth of articles. Inside your database, which assuredly your archive would take form in, inside your database, you might have like a giant spreadsheet with one column being author, the next column being the date of publication, the next column being, say, like the subheadline, then the headline, and the article text, and so on. We turn every one of those rows into a number, and we give ChatGPT that number. And when we type a request into ChatGPT, and this, by the way, is what semantic search is, when we type a request into ChatGPT, it will turn your request into a number. And for reasons we don't quite understand, the relative meaning of all of those documents, what is represented inside those documents, what is discussed, you can think of that as those numbers as actually being the coordinate points in a system of meaning, in a spatial system of meaning. And so when we talk about embeddings, often we're also talking about vectors at the same time. And this is getting a little bit too deep into the math. But basically what it means is that if you turn your documents into numbers, and you insert those numbers into a database, and you consequently look up a search term, and you turn that search query also into a number, you can actually rank your database by the most relevant documents first. And this is how Google works. So Google, in fact, embeds every web page on the internet. And they also embed everything that you type into Google. And so when you type dog into Google, it returns you first all the pages on the internet that have to do with a dog, but not only a dog. It will also return you web pages that have to deal with a hound, or like a mammal, or cats, and things that are like dogs. And so embedding lets you do something called semantic search.